Wonderful. Welcome everyone to our amazing June public event. Let's go ahead and get started. I'm going to welcome everyone to this great talk on the language of the stars, the wonderful book written by Nathan Hellner-Mestelman, who's joining us here from the Victoria Centre. Now, before we get to that, as always at the Montreal Centre, we like starting with a land and sky acknowledgement, acknowledging that we are here in the Montreal area on unceded Indigenous lands of the Mohawk and the Algonquin peoples, but also that the First Nations across Canada, as well as the Métis and the other Indigenous individuals, Inuit, they've been shaping and strengthening the ties to the land and the waters and sharing the skies with us. And you can often see this sharing of the skies with the way in which we refer to the moon of the particular month and how it connects to nature. And if we go to the grocery stores, I know Maxi has a new sale coming out tomorrow with the Quebec strawberries, even more on promotion. There was a full shelf of them this morning when I went in. Incredible, gorgeous, red, ripe, sweet strawberries, as we refer to this as the strawberry moon. But other fruits are still small and we don't want to pick them. And the Mohawk of this area do refer to this moon as the fruits are small moon, so that we don't accidentally start picking fruit too early and it doesn't sustain us through the winter times. Now, before I get into a little bit about the RASC and the RASC Montreal Centre, I want to turn it over to our honorary president, Dovid from Arizona, to give us our literary reading to start us off.
Well, thank you very, very much, Corinne. It's wonderful to be here, and it's wonderful that I remembered to be here tonight. Anyway, tonight I want to discuss briefly a little game that was being played centuries ago when, they have just 20 or 30 zero magnitude stars around the heavens. We have maybe several dozen first magnitude stars, a couple hundred second, and several thousand sixth. And by the time we get to 15th and 16th and 17th magnitude stars, there are billions of them. And so it would seem that if you continued this all the way out into space forever, there would be no place in the sky that was not occupied by a distant star. And if that were the case, the sky should be so bright at night that we would burn up and die and never be allowed to be here. And that paradox is now known as Olber's paradox. And I'd like to sort of introduce you to, I think, the person who solved it. It was not Hubble, although most people say it was. It was actually over a century before Hubble. Edgar Allan Poe, the poet, actually solved it. He wrote Eureka, a prose poem. I think it was the last thing he wrote in his life. And he writes, were the succession of stars endless, from the background of the sky would present us with uniform luminosity, since there would be absolutely no point in all that background at which would not exist a star. The only mode, therefore, in which, under such a state of affairs, we could comprehend the voids which our telescopes find in innumerable directions would be by supposing the distance of the invisible background so immense that no ray from it has yet been able to reach us at all. And I think that was the correct answer to Olber's paradox. There's a little more I'd like to share with you from Edgar Poe, and those are 3 stanzas from The Raven. Presently my soul grew stronger, hesitating then no longer. Sir, said I, or madam, truly your forgiveness I implore. But the fact is I was napping, and so gently you came rapping, and so faintly you came tapping at my chamber door, that I scarce was sure I heard you. Here I opened wide the door, darkness there, and nothing more. Deep into that darkness peering, long I stood there wondering, fearing, doubting, dreaming dreams no mortal ever dared to dream before. But the silence was unbroken, and the darkness gave no token and the only word there spoken was the whispered word, Lenore. This I whispered, and an echo murmured back the word, Lenore, merely this, and nothing more. Then this ebony bird beguiling my sad fancy into smiling, by the grave and stern decorum of the countenance it wore. Though thy crest be shorn and shaven, thou, I said, art sure no craven, ghastly grim and ancient raven, wandering from the nightly shore. Tell me what thy lordly name is on the night's Plutonian shore. Quoth the raven, nevermore. Thank you very much, Kareem, and back to you.
That was wonderful, David. As always, thank you so much. It's one of the wonders of the Zoom era since COVID that we've been able to have you on with us as if you're actually here in Montreal. And
Yeah.
for those of you who aren't often in our clubhouse, next Tuesday, David and I will both be on the next Global Star Party as well on Tuesday night with Explore Scientific. And you can always catch his literary readings at the start of those Global Star Parties, at the start of our clubhouses, and of course, our RASC Montreal public events. So
Mm.
thank you, David. And I'm glad today we're featuring a fellow author. We've got yourself, we've got Russell Freilich, our former outreach coordinator, and we've got Nathan joining us from Victoria. We've got several authors here on the Zoom, so I'm hoping that we're going to get some good advice for when some of us want to start working a little bit on our literary journeys. Um, so for those of you who are new to the RASC, we are a Canada-wide organization, 30 centers from coast to coast to coast, more than 4,000 really great, not just amateur astronomers, but also astrophotographers, hobbyists, professional members, educators, and it's people who want to share and have a common night or a common forum to enjoy and explore our passion in space and astronomy. So here in the Montreal Centre, we have been here for over 107 years now. We are a really vibrant center. We have bi-weekly events. If tonight wasn't a public event, it would have been a Zoom clubhouse, or if it wasn't a full moon, we might have been at the Arboretum. On Saturdays, we go out observing. We have a clubhouse at the Morgan Arboretum with our Bellevue Observatory. We also have a library collection at John Abbott, which I'll talk about in a moment. And one of our pride and joys is our newsletter, Skyward, which comes out 6 times a year. And there in the most recent issue of Skyward, you can see young Luca, who's joining us here tonight, and who doesn't know yet how his name is used in Nathan's book. So we're going to hear a little bit about that later tonight. But Luca is our most recent Explore the Universe certificate recipient. And this is him doing a little bit of his observing for that wonderful observing challenge. Now, our members events coming up this summer, for those that are members and for those that aren't but are considering membership, we have a movie night this Saturday. The movie is a mystery movie. Well, it's a space movie, but it's a mystery which one it is. You'll find out on Saturday, but our movie nights are known for incredible treats thanks to David Schumann, our VP. This past Monday, we had our library reopening, the Isabel K. Williamson Library, and Dovi joined us from Arizona, and we were fortunate to have with us in person Frank Hughes, who's the former NASA chief of astronaut shuttle training, as well as the one who trained the Apollo astronauts with the moon simulator. And after that amazing talk, I had to start a few documentaries and reading a few things, and even started the series For All Mankind that I've been waiting to start. So my wife and I started watching that. And in the very first episode, they refer to that alarm that rang in the moon simulator. So we're immediately like, Frank talked about this. We also have our members liaison, Nicole Laporte, who gives a monthly night sky overview on the first Wednesday of the month. And for the summer, if it's clear, it'll be at the Arboretum. If it's cloudy, stay tuned to your emails to see whether it's at the Arboretum or on Zoom. And we have Saturday observing nights that our observing director, Santiago Lopez, has planned out for us to go to darker skies. We also have 2 public events coming up just as the summer will end and the fall will be ready to begin. We have the annual Papacosmos Perseids meteor shower event which will be on either the Tuesday or Wednesday near the maximum of the Perseids meteor shower. And our Townsend keynote lecture, our annual most prominent speaker that we want to really kind of have to set the tone for our fall and winter public events, will be on Saturday, September 6th. It's going to be Lisa Dang, who's recently from the Institute for Research on Exoplanets at University of Montreal and is now a professor at University of Waterloo. But for tonight, we are fortunate to have with us Nathan Hellner-Mestelman. Now, I had the opportunity to work with Nathan a little bit during COVID, both as a presenter with the wonderful global star parties that we had, as well as, in fact, Nathan, and he might even talk about this a little bit, but he joined our Montreal Centre member, Tara Jaffer, along with several other astronomy youth from the US, from Brazil, from Nepal, and they created an online youth society to explore space and do workshops. And Nathan gave a couple of talks and workshops, so did Dara, so did Deepti. It was really a really fun group to see these youth get to explore their own passions. And Lucas, one of our members who is currently a university student here, was also in that committee and actually brought him closer to the RASC overall. Now, apparently, since COVID ended, Nathan has just gone incredibly deep in his passion for science communication with two books now published, if I'm not mistaken, including this one, The Language of the Stars, that we're going to hear about tonight, and also Cosmic Wonder, and had a short documentary film entered into film festivals in the Victoria area, and I believe also a national film festival. Is that right, Nathan? Yes, excellent. So I'm going to read off of this slip because it does a better job introducing Nathan than I will. Nathan is an avid writer and science communicator. Now 17, he's the author of Cosmic Wonder, Our Place in the Epic Story of the Universe, a member of the Royal Astronomical Society of Canada, and runs the planetarium at the Dominion Astrophysical Observatory at times. He's a fervent slam poet, which that part I didn't know, lover of stand-up astromedy, which I did know, and a nerdy beyond all reason. And his webcomic was actually named Nerd Anomaly, and I absolutely loved it. And I'm glad to see elements of it in his books. So Nathan, we are all yours, and take it away.
Thank you so much. It is great to be here. It's nice to see you again, by the way. Yeah, it's been a while.
Thank you.
Um, let's see, where do I begin? Well, I got to know Kareem in 2021, September, when I first went on a global star party. And that was a connection from Laurie, who's pretty prominent in the Victoria Centre of the RASC. And yeah, and then I think you connected me with the Montreal Centre, who connected to the Denver Centre, and yeah, we set up the Cosmic Generation. Um, that was a year after the lunar eclipse that kind of made me briefly freak out about the universe and then become fascinated with it. It was January 20th, 2020, I believe, where that was the lunar eclipse where the asteroid impacted mid-eclipse, and I wasn't looking at it because I was eating a cookie at the time, but one of my friends was looking through the telescope and saw the impact, and for that I'll forever have a bane against cookies and forever have a grudge against my friend for being one of a few hundred people in the world to see an impact. But, that got me thinking, these sorts of things happen all the time. It's just that usually we don't see them because we're here on Earth, sometimes eating cookies, sometimes just not even looking in the right direction. But trillions of these impacts are happening all the time across the universe. It's just such a big place. So that's what kind of got me writing. I wrote for a while for SkyNews magazine, then that went out of business. I was actually on the council when they made that decision. It was not fun, but that's fine. Uh, anyway, so well, after Sky News, I kind of just got into writing manuscripts, and then eventually I got Cosmic Wonder, the first book published. But there were some things in Cosmic Wonder that didn't quite make it into the manuscript, and it's totally not because some author decided that they were going to take the three-part series that they were supposed to do and put it all in one book. Uh, yeah, he might have chosen to do that. I don't know. I don't know. But anyways, there was enough content for a sequel. So the theme of The Language of the Stars is kind of on par with the title. It's common threads that sort of feature in the universe. It's things that we have in common with other life on Earth, with the universe on a more, subatomic level. And it's also sort of toying at the speculation of if we find intelligent life, if we make contact with intelligent life, are there common features that just by sheer chance alone we might share in common? And sort of speculating on that by looking at what we have in common with distant branches of life on our own planet. So without further ado, I would love to present to you the language of the stars. Perfect. Okay, so basically, I want to begin by posing the question, what would you do if you were tasked with texting a new friend on a new phone? And let's see, what would you have to communicate with this friend? Let's say you had to communicate uh, a very, very vague selfie describing what you look like, your height, your average location, your home address, the name or the type of device you sent the text on. This could be a challenge because your friend does not speak your language. In fact, your entire culture is about as foreign to them as Shakespeare is to a hamster. And it might be difficult for you to arrange a meetup given that your friend is 60 trillion kilometers away. But aside from all that, it is possible. There are some things that you might be able to understand with an intelligent life form on another planet. And this was our first attempt in 1974. This is the Arecibo message. And this was truly the first text humanity ever sent into some kind of cosmic group chat. So, as for things that we might share in common or mutually understand with alien life, this is as far as we got in 1974. We have the numbers 1 to 10 in binary. We have those binary numbers representing the atomic numbers of hydrogen, nitrogen, carbon, oxygen, and phosphorus, which, if you don't know, are like the big five when it comes to life on Earth. And if you combine those binary numbers of atoms together in order of the way they appear in adenine, thymine, cytosine, guanine, the nucleotides of DNA, well, you can kind of communicate what our genetic code looks like, even more if you show the shape, the double helix shape of DNA. So what we've done is basically give the numbers 1 to 10 in binary because base 2 is basically just, well, the second one up from literally just doing tick marks. So base 2 is generally accepted as the most common system of counting that different civilizations may understand. And if they understand binary, then they could potentially infer that we're talking about the big five elements of life, arrange them in the order of the molecules of DNA, talk about the double helix shape of DNA, give a stick figure of a person turned vaguely on its side, the height of a person. You might wonder what units you're measuring the height of a person in here, because aliens aren't going to know what feet or meters or inches or barleycorns or leagues or fathoms are. That is actually the wavelength of the message used kind of as a ruler or a baseline measurement. So this was about 9 of those wavelengths tall. And what else? We have the world population as it was in 1974, and we have the solar system with all 9 planets because we still loved Pluto back in 1974, of course. With the third planet from the sun being raised up a little bit because it's special, it's the Earth, it's where the message came from, and the Arecibo telescope itself. Hence, you're texting your friends the device that you're texting with. It's the Arecibo telescope. So this was the best we got in 1974. But as it turns out, there's a rather deeper topic we might share in common. And I think if we want to talk about some of the more profound things we might share with a life form from another planet, we need to talk about something known as dark matter. You might have heard of dark matter. In fact, it's sparked a lot of interest lately in the astronomy community. It's a it's a substance that's out in space that we currently don't know much about because it seems to be massive, huge, literally weighing 6 times more than the rest of the universe combined. But it does not appear to interact with matter at all. Physically, it just passes straight through. The only way it interacts with the matter of the normal universe is gravitationally, as in it's so big that it pulls on, well, basically the entire universe. It throws whole galaxies around. In fact, a good way to compare this is even just looking at the way our galaxy spins, it spins so fast that the stars around the edges should be yeeted off into space like children at the edge of a merry-go-round spinning way too fast. And yet, some impressively powerful force holds the stars at the edge of our galaxy in. So even though there's centripetal force pushing outwards in all directions, it keeps them in a stable orbit. The mass of our galaxy alone should not be enough to do that. So it hints that there is something in our galaxy that weighs 6 times more than the galaxy itself. And that is more or less what we think dark matter is. Now, for those of you who have been to Victoria or have checked out the Hoyne Brewing Company, you'll know that dark matter is also a local brand of beer. And for this reason, I think it's important to distinguish a few, you know, distinct traits between the two. Here's a little flowchart I created, or a little crisscross chart of dark matter versus dark matter, and I think there are quite a few defining traits that separate them both. One weighs 7 times more than the universe, the other weighs about 20,000 kilograms since it was first initiated. Um, One is always passing through you every single second of your life. The other is only really doing that if you're a heavy drinker. I won't really assume what your lifestyle is. But anyways, they're not the same thing. So you might be wondering why the heck I'm bringing up dark matter beer in a talk about astronomy and what we might share in common with alien life. Well, turns out when you're looking at common threads between distant life forms, there is actually no better place to start than beer. And here's why. Let's talk about a brief history of time and other beer-related herbs. A brief history of time. So if we take a world map here and we look at where beer first came from, well, you're not actually going to be able to answer that question because beer technically first originated, my bad, let me back up a little bit. Chocolate tinted beer, which is what dark matter beer is, has its ancestry in Mesoamerica. It kind of originated from a drink called Xocolatl, which was a Mesoamerican sort of Aztec beverage in 1400 BCE. So that's the first time that cacao beans were actually fermented into an alcoholic drink. But the first beer, you have to go way further back. This is actually in ancient Sumer. Excuse me, it was known as Kaz. This is 10,000 years ago, and then in China, 9,000 years ago, and then in Egypt, 8,000 years ago, and then in the Indus Valley, 3,500 years ago. I mean, this was everywhere. It happened in what's now known as Australia, it happened in Russia, it even happened in the Incan civilization. Beer has independently evolved over 30 times over our planet's history, just because where there are humans, there is agriculture, and where there's agriculture, there is fermentation, and beer just happens. So, while we're on the topic of common threads that have appeared multiple times in very distant regions of the world and distant regions of life, beer is an excellent starting point, and this gets into something known as convergent evolution, which is basically just a fancy way to say it's not really evolution because it's not really descended from a common root, but they all have the same trait, just evolved coincidentally by sheer chance alone because it worked out so well in each of those places. There's common threads all over the place. In fact, even counting, okay, so the point is, if you excavate like the relics of any of these ancient civilizations, you're going to find beer. But if you excavate the relics and you just go to these places and start, like, grab a pickaxe and start digging, there's another common thread you might find. You will be arrested by UNESCO because that's an archaeological heritage site. However, with an excavation license, there is yet another common thread you may find, which is the number pi. The number pi, the ratio between the width of a circle and the circumference. And the reason why pi is so popular is just because it seems to be a natural checkpoint in the curiosity of humans as they develop counting to want to know what the ratio between the circumference of a circle and the width of the circle is. So counting kind of began around ancient Sumer, Egypt, with ancient cuneiform script, but pi was also discovered in ancient Babylon, it was discovered in Sumer, it was discovered in Egypt, it was also discovered in the Indus Valley, it was discovered in Greece, and it was also discovered in China. So pi has been independently discovered over 20 times independently over human history. And the weird thing is, the counting systems used by these civilizations were not even remotely similar to each other. The Babylonians used a base 60 counting system. That is like 60 characters before you add a second decimal point. The Mayans used base 20, the Sumerians, the early Sumerians at least, used base 12, and then we, along with the Nagari system that we got our counting system from, used base 10, and that's kind of stuck around. But by all means, the people who discovered pi were not using the same counting system. Their numeral systems looked almost alien compared to each other, and yet they all stumbled upon this number, pi, because that's the nice thing about math. You don't need to be using base 10. There's nothing special about 10 in math. It's just the one that we've used the most in the modern world. But if it counts, it works. And it works so much that if you put that in binary and beam it into space, like we did from F Victoria in 1999, if their counting system is anything like us and they have the same sort of curious drive, they might have stumbled upon pi. So in 1999, people beamed the number pi deep into space in binary, just out of the sheer chance that someone out there might be listening and might know what the number pi is. So that's another example of convergent evolution. We have stumbled upon pi lots of times. But it's more than that. We can talk about convergent evolution from a biological point of view, too. If you take that sort of so-called tree of life, starting from DNA, the first common ancestor, all the way out 4 billion years into the future to all the 8.7 million species we have today, you can talk about, where we got some of our traits from. Humans, the tetrapods, the ones with 2 arms, 2 legs, or 4 legs, that evolved once from a tetrapod called Tiktaalik, a fish-descended creature, an amphibian that crawled onto land about 400 million years ago. By the way, since biologists love their taxonomy, but still haven't created any taxonomy boundaries between Tiktaalik, the amphibian, and modern mammals and reptiles. That means technically, since Tiktaalik is a fish, or fish descended, and since humans are descended from Tiktaalik, that means humans are fish. Humans are fish, mammals are fish, dinosaurs were fish. And so, yeah. So when those studies come out that says, I don't know if you saw the study a while back that said research shows that fish can recognize human faces. And I was like, yeah, I'm glad that I can recognize human faces. That's good. That's reassuring.
So when they say there's more fish in the sea, they mean it literally?
There's more fish in the sea. I suppose so. Although that raises the question, there's always more fish in the sea unless there are more reptiles, mammals, and amphibians combined on land than there are fish in the sea, because in that case, there's actually more fish on land, but remains to be determined. So
Good
we'll
point.
see. The point is, we evolved traits from one source, but that's actually more the exception than the rule in biology. If you look at the history of life, and sorry, I'm just gonna move this side panel a little bit. Are we still screen sharing?
No, it stopped.
Oh, okay. Never mind. I will put that
There.
back on.
I love your animations. I'm so glad to see them again.
Thanks. Yeah, I'm glad to use them. Um, okay, there we go. If you look at wings or just wing-powered flight, that has not evolved once, but 4 times over life's history. It evolved once with the insects, once with the dinosaurs, once with the pterosaurs, which were kind of the distant, non-related cousins of the dinosaurs, and once in bats, which were mammals, which are not even remotely related to insects or dinosaurs or extinct reptiles. I say dinosaurs because, well, dinosaurs did not have wings originally, but they became the birds, which do have wings now. So that's sheer coincidence. There's no relation between the pterodactyl and birds. Those were completely different branches on the tree of life that just happened to evolve wings because it was really beneficial for survival. So convergent evolution was happening. Echolocation evolved twice, once in bats and once in dolphins. Those are 60 million years separate on the tree of life. Even brains, which I'm going to talk about a bit later, might have evolved twice in life's history, once in the comb jellies and once in animals. And if you look at photosynthesis as a whole, especially C4 photosynthesis, which is like a new, modernized, amped up, recent, and I mean recent, like 40 million years ago, recent version of photosynthesis, that popped up over 65 different times all around the same time in completely different species just because of how beneficial it was for survival. Even eyesight, just Organs that can see, that evolved over 65 different times, from eye spots on protists, bacteria, and amoeba to sort of the camera globules in octopi to the arthropod eyes, the sort of the camera eyes of insects to the more ocular bulbs that are in modern animals and humans. Eyes have evolved so many times. It's kind of remarkable. So when you look at how many times these common traits have evolved, should we be surprised? Well, we live on a planet that has a thick atmosphere, and if that's a niche that life can fill, you can bet that wings are going to be evolving eventually. We orbit a star whose radiation spectrum peaks at green, and so when you think about how many times green chlorophyll has evolved, C4 photosynthesis, it is remarkable, but it's also not surprising given that the sun's spectrum just happens to peak at 500 nanometers. Plants are going to dig that, literally. So when you look at how many common traits have evolved here on Earth, it really gets you thinking around other stars with similar conditions. Could we expect these common traits to have evolved just because of how similar the conditions are? As in, do you need a common ancestor to produce common traits, or do you just need common conditions to produce common traits? And that's a theme that my book really explores because I find it fascinating that these traits evolved so many times without a common ancestor. It does not stop there, though. When you think about the fact that we came from the same planet, but our planet also came from the same universe as every other planet in the universe. And at the very beginning, the conditions were kind of the same everywhere. We got a huge sea of quarks, and those combined into protons and neutrons. And the very first atom that appeared about 400,000 years after the Big Bang was hydrogen. And basically everywhere, all this hydrogen just collapsed out of space. And the cool thing about this is because it appeared at the same point everywhere, all this hydrogen started permeating the universe, and hydrogen does something really funky when it exists out in space. It emits this radio wave called the hydrogen H1 line, which has a wavelength of about 21 centimeters, 21 and a little bit. And, excuse me, the cool thing is, no matter what the hydrogen is doing, whether it's superheated hydrogen or frozen hydrogen, whether it's in space or in an atmosphere, whether it's, excuse me, sorry, whether it's gaseous hydrogen or liquid hydrogen or solid hydrogen, happy hydrogen, sad hydrogen, doesn't matter. It's going to emit this wavelength of 21.1 centimeters. And that means when we started sending probes that were going to go into the galaxy in 1972, the Pioneer probes, we literally used that hydrogen wavelength as the universal yardstick. Because again, extraterrestrial life is going to have no frickin' clue what a meter is or a foot is. The only thing they'll know about is the universal constants that they have measured along with us. And so, in addition to using like the wavelength of that broadcast back at the RASC message, since this is a plaque and it doesn't really emit radio waves, the metric of measurement that was used, that Carl Sagan, who was the one who helped design this, decided to use to communicate lengths here, was the hydrogen H1 line. And I think that's really cool because hydrogen is the most common atom in the universe. And so any civilization that's got even an ounce of an appreciation for chemistry is going to know about hydrogen and is going to know that it makes up most of the universe and probably will know about this radio wave too, the fact that it emits this really funky 21.1 centimeter line. And so if you look at this sort of, it looks like a dot and then another dot here and a line between it, that represents one hydrogen radio wave flip, and that is 21.1 centimeters. And if you notice, well, first of all, we've got human figures, human portraits. You don't need to worry about clothes when you're sending a portrait to the stars, because do you need decency when you are literally naked in the vacuum of space? I don't think so. We've also got the solar system. 9 planets, because again, 1972, we loved Pluto back then. But you also might notice, well, we've got the hydrogen H1 flip to measure distance, and we've got this little tick, tick, tick dash mark next to the humans. So as you can see, we have a dash at the woman's feet and a dash at the woman's head, and then we have the binary number 8, or dash dot dot dot, inscribed between those two height marks, and that means 8 times the hydrogen H1 flip, which means 8 times 21.1 centimeters, which is roughly the height of the average female, at least in 1972. I have heard humans are getting taller gradually, so we'll see how accurate that is by the time the probe is discovered. But anyways, so that is sort of just a height marker because we obviously didn't want to come across as 7-inch hobbits, but we also didn't want to come across as Godzilla-like monsters. So this gives a sense of how big humans are. And there's also this, which you might be wondering, this is a map, a home address for humanity. So this is probably humanity's best attempt yet at showing the galaxy exactly where we live, for better or for worse. And what this is exactly is a map, not exactly a postal code or a home address, but a map to the nearest dead stars or pulsars, neutron stars, stars that have collapsed at the end of their lives and have turned into tiny balls of neutrons spinning hundreds of times a second, so fast that they shine beams of radiation into space that spin around and appear to flash from our point of view. It's like sending your address in relation to the nearest graveyard. Like, I do that all the time, it's fine. And the interesting thing is, because pulsars are so inherently rare, there's really no mistaking one when you see it. And the reason that you don't see it is because they don't usually shine in visible light, but they do shine in radio light. And well, any alien civilization who's advanced enough to listen for extraterrestrial messages is going to know what radio is. So hopefully they will know what pulsars are. And to denote exactly which pulsar is which, we have even inscribed, or not we, I was actually not born then, believe it or not, but in 1972, Carl Sagan inscribed the frequency of each flashing pulsar in dashes and dots in binary as well. And in this case, that's not the length of the hydrogen H1 line, that's the frequency of the hydrogen H1 line. So we've really made double use of that wavelength, both as a measure of length and a measure of time. So that's the most detailed direct message into the cosmic group chat we have sent. So in terms of what we might understand on a purely language-based level, this is kind of the peak so far, but there might be much more in the future. Anyway, let's go back to dark matter. Sorry if that's a bit of an abrupt change, but if we're going to talk about what else we might share in common with a theoretical life form from another planet, we need to talk about not the beer, but the actual legit dark matter substance. Because hydrogen was the first element to appear in space, and because it existed literally everywhere, the same processes started happening everywhere in the universe. So around 100 million years after the Big Bang, the stars started collapsing all over the place, all around the same time. The first stars, 100 million years. And then almost immediately, you start getting these giant black holes, and you start getting, excuse me, these giant galaxies. It happens really fast. Within the first 300 million years, you've already got galaxies forming. That is strange. For a universe like ours, as large as ours, that is seriously an early bloomer. That is like our universe being born and then hitting puberty at age 1. That is not something that you would expect for a universe as large as this. And the reason that stars start clumping together into galaxies so soon is because there was something massive pulling these regular matter stars together. And that is where dark matter really saves the day because it gets galaxies stirring less than a billion years after the Big Bang. It gets black holes growing to the point where they can actually support galaxies around them. So we really do have dark matter to thank for setting up the conditions. And scientists think that it's because stars got so big that they actually formed black holes inside them, and then they kind of got devoured from the inside out. So really, dark matter was the culprit that started this whole symphony of galaxies off, and really what laid the foundations for life as we know it, here and perhaps elsewhere too. Now, our solar system in the scheme of solar systems had a pretty average beginning. So let's see. So it usually is accepted that it collapsed from a cloud in the middle of the galaxy, just like the rest of the solar systems did. And the neat thing about that is since we formed from a cloud that was out there in the galaxy, there's really nothing that distinguishes the matter that makes us up versus the matter that just makes up the rest of the galaxy. It's just that it happens to be a bit more concentrated with us. But really the point is, over a very long and convoluted time span, the stuff that makes up the Milky Way gradually got stirred up into molecules, into complex chemistry, and eventually into life, which made Luca. And you mentioned you mentioned that I used Luca's name in my book. Yes, I did. Luca, you're also published in Nature, I should have you know, and there's a Nobel Prize contending on your name too. LUCA stands for the last universal common ancestor, which lived about 3.8 billion years ago and was a single cell that kind of just ate methane for a living and then cooked up a bunch of energy and used that to copy a small strand of DNA that lived inside it. Now, the cool thing about LUCA is that even though it used DNA, it was not the first genetic code to exist. LUCA was the first supposed cell to give rise to everything we see today, but there was a lot of DNA and a lot of genetic code stirring up before then. This is the truly mind-boggling bit that just kind of drives me crazy about convergent evolution, in that genetic codes evolved more than once on this planet. Not even just wings or eyesight or photosynthesis, but literally genetics. We're pretty used to DNA, deoxyribonucleic acid. It steals the show. I mean, it's literally everything alive today uses DNA. That would not have been possible without its younger cousin, RNA, which scientists actually believe came first and kind of laid the blueprints for DNA. So we have ribonucleic acid, RNA. That was sort of the first primordial genetic material. But there was more. There was also threose nucleic acid. There was peptide nucleic acid, hexose nucleic acid, glycose nucleic acid, HNA, PNA, TNA, GNA. These are all things, excuse me, that developed early on in life's history that were quite prominent at the beginning, that just weren't as successful as DNA, and so didn't become the foundation for all of life's kingdoms today, but certainly no less prominent in the early Earth. The fact that over 6 different strains of genetic information evolved really just makes me wonder, even though only DNA exists today, how common could this sort of molecular genetic storing be, stirring up in oceans on distant planets? I mean, when you think about the fact that we could have had TNA, PNA, HNA, and GNA-based chemistry before DNA sort of became the dominant strain of genetics, I mean, how many alternate strains of life could be possible then? I would get better PNGs of these compounds, but my CPU doesn't handle that kind of RAM. I could run out of 3-letter acronyms or TLAs before I get to that point, though. That's fine. Anyways, so we got even more common threads as life evolved, not because of convergent evolution, but because of a really pesky sort of delivery service for DNA. I like to call them the FedEx postal trucks of genetic information. In fact, these are the viruses. We owe an entire 8% of our modern DNA to viruses, more specifically retroviruses. Uh, the retrovirus that has gained most of our attention today is HIV. That is a really common or a really well-known strain of retrovirus. And it's pretty well known because of how destructive and harmful it can be. But it's certainly not the only strain of retrovirus that affects humans. And most retroviruses that enter our bodies are actually harmless. There are millions of strains of retrovirus. And for the most part, sorry, I should probably distinguish first what makes a retrovirus retro. It's the fact that most viruses go straight into the nucleus and then break apart, shoot the DNA in, get it into the little machines that copy DNA, hijack the cell, blow up a bunch of copies of themselves, and then boom, you've got an army of viruses. Everything gets destroyed, and the cell explodes with millions of viruses leaking out. Retroviruses are a bit more sneaky. They actually merge with the nucleus, insert their DNA into the human genome itself inside the cell, and then when the time is right, either they get that little snippet that's nested within the larger genome to be copied, and then suddenly you've got a huge army, boom, cell is destroyed. Or, for the most part, most of the harmless strains, it just stays there. They just leave their DNA in the cell, and it just kind of stays there, either doing nothing or sometimes even providing a benefit to the host organism. We owe a lot to retroviruses, actually. The myelin in our brains was a genome that was delivered by a retrovirus. What else was there? The placental tissue, the ability for a placenta to affix itself sort of to the uterine wall, that was a string of genetic code delivered by retrovirus about 200 million years ago. And even this funky molecule, HAP2, a gene that lets two cells fuse their membranes. I mean, viruses need to fuse their membranes with cells to get their genetic code inside. We could not have had that capability without retroviruses delivering it to us. And once cells could fuse their membranes, bam, in an instant, sex became possible. And therefore, everything more complicated than sea sponges got to exist. So if it weren't for HAP2, a single virus perhaps delivering its genetic code into some unsuspecting cell, we would still be at the sea sponge era, and SpongeBob would still be the most popular TV show. But it isn't, because HAP2 got delivered, and suddenly life became incredibly complicated, because suddenly organisms could mix and mingle their DNA. And after that point, multicellularity, or cells teaming up with other cells, became a thing that happened. Not just every once in a while, but over 25 different times, coincidentally, at around the same point in history. Again, convergent evolution at its finest. Multicellularity, or lots of cells living together, just suddenly started popping up all over the place. This is what led to the powerhouse of the cell, with the mitochondria blooping inside a sort of eukaryote cell back then, and suddenly we have the powerhouses. We can make ATP. It's the same reason that plants now have chloroplasts. They were once free-swimming cyanobacteria, but now they live inside plant cells for the same reason. Cells were able to fuse their membranes. And then there's this other species up here called dinoflagellates that kind of take this whole cells eating cells thing to a whole new level. They actually employ diatoms inside them, and the diatoms have little algopods inside them. So this is like a three-cell bureaucracy of sorts. The algopods make energy for the diatoms, make energy for the dinoflagellate, and if any one of them fails, they all die. So this is sort of the benefit of multicellularity, is that suddenly cells didn't need to be know-it-all survivalists anymore. They could count on their neighboring cells to cover their survival needs for them, and teammanship became a thing. This, again, happened 25 times convergently. Different points of Earth's history, same sort of result. And this is all thanks to a wild common thread that cells obviously have with teenagers, which is they absolutely snap under peer pressure. Can relate. Can relate. Because when you take a stem cell or an undeveloped teenage cell of sorts and you give it a certain compound, it will shut down all its genes except for a certain brand. So if you give a stem cell something like CEBP, it will shut down all its genes except for the skin cell ones. Or if you give it a different chemical, it'll become a muscle cell. Or a different chemical, it'll become a white blood cell. So the point is, what happens is these cells start taking on roles, specialized roles, and then they start emitting these chemicals that are basically just a peer pressure cellular way of saying, "Psst, it's pretty great to try this role, you should do it too." And so this chemical cascade spreads, and suddenly you have specialization, you have organs. And one of the first organs to develop was eyes, or photoreceptor cells, cells that can absorb photons and convert that into electricity. And that's the reason that eyes evolved so many times in the beginning, because it was such a popular role for cells to have. 65 different times. And even brains. This is the really mind-boggling bit that I like to talk about in my book, which is it was it all comes down to three species: modern animals, jellyfish, and sea sponges. And for a long time, I mean, people know that jellyfish have brains. Jellyfish have brains, for the record, and animals have brains, and sea sponges do not have brains. So the idea was that, sea sponges look less developed than jellyfish and animals, so probably they developed earlier than us, and then they branched off from our tree of life, and then the jellyfish animal ancestor got a brain all of a sudden. It evolved a brain, and then it gave rise to the jellyfish, which adopted their brains, and the animals, which also inherited their brains. So this was kind of the common idea for quite some time, until a study just a few years ago that, well, 2008, I was 1 year old. But anyways, that revealed that, as a matter of fact, sea sponge fossils are younger than comb jellyfish fossils. And the weird idea that this kind of forces us to at least deeply consider is that, in fact, the jellyfish might have split off from our tree of life first, and then the sea sponges kind of had an ancestor with the animals, and then the sea sponges broke off, and then the animals. And so what that kind of forces us to consider is the jellyfish broke off from our tree of life, and then the jellyfish evolved a brain. The sea sponges continued evolving with no brains, and then the animals and the sea sponges diverged, and then the animals evolved their own brains, and the sea sponges did not. So that kind of hints at the idea that brains, whole brains, might have evolved twice in the history of life on Earth. And when you think about, like, brains are incredibly complicated. It's one of the, like nature's most sophisticated evolutions. And when you think about the fact that that could have happened twice on the same planet, it really makes you think about what's possible on another planet altogether that might have similar conditions to Earth. What common threads might we share in common with them? Now, if we get a little bit further ahead, because of how much mixing there is, because cells are blooping inside other cells, because viruses are carrying packages of DNA back and forth, because we all share these common ancestors, because convergent evolution keeps making the same traits pop up over and over again, we share a mind-baffling amount of DNA with life on this planet. Humans to humans alone is 99.92% genetic similarity. That means the only thing that differentiates me from you, from strangers, from anyone else on Earth is 0.08% of a genome's difference. Just let that number sink in for a bit. That means that no matter who you find on Earth, they are 99.92% you genetically. If you trace that back, that means that everyone on Earth is a 50th cousin or closer, which family reunion, I suppose. This is a nice zoom. Family reunion time, that's great. But when you extend that to other species, humans are obviously mostly related to humans, obviously, but when you extend that to other life, we still share a drastic amount in common. Chimpanzees, with gorillas, with lemurs, with rhesus monkeys, over 90% of our DNA is shared with them. And in fact, no matter how far you look on the tree of life, you're going to share stuff in common. There's going to be common traits with everything because we all come from Luca, the last common ancestor, and convergent evolution happens, and they're made of cells, we're made of cells. Even amoebas have over a fifth of their genome in common with human cells because they are cells, we're made of cells, we all need common things to survive. So really, this is sort of the poetry of DNA that I just love to talk about, which is we share something in common with literally everything alive on this planet. And when you think about it, we might share something in common with something that is not from this planet too. So really just to wrap up, if you go right to the modern age, some of the most recent species that were not humans, our very most recent primates, were the Neanderthals and the Denisovans. These were the last technically non-human species. They were literally almost human in every way possible, but by purely biological definitions, species meaning like you can breed together and it actually works out. They tried that and it didn't really work out with humans, which is partly the reason for their extinction, in that there was just too little of them, too many humans, and crossbreeding did not quite work. So, but the point I'm trying to get at is some of the most human things we think of as being inherently human were not actually human creations at all. They were invented in the last few 100,000 years, but not exactly by humans. The first evidence of counting was at Border Cave in South Africa. It was discovered in 2013, and it was actually more of a Denisovan creation, as in Denisovans lived in Border Cave in South Africa 40,000 years ago, and they took bones and they took sharp teeth and etched marks into bones to count their food rations for the season. And really, this means that the first evidence of counting, of using symbols to represent how much of something there is, was not actually a human creation at all, but a Denisovan one. The first jewelry, not a human creation, but a Neanderthal creation about 40,000 years ago. This was discovered in Grotte Cave a couple years ago, and it was actually found in France. And it was stringed ornaments of teeth and bones and leaf patterns. And those, I mean, to me, that's kind of profound because we think of jewelry, we think of aesthetics as a human tendency, but really, these species were so similar to us that they shared common interests too. Jewelry, first made by Neanderthals 40,000 years ago. Even burial grounds were actually first used by Neanderthals, the first species to pay tribute to their dead, to honor the deceased, to bury them, to decorate their graves, was 100,000 years ago by Neanderthals at Shanidar Cave. And even the first sailing expeditions. This is a bit more speculative, but in 2013, there were stones called Mousterian rocks that were discovered on the island of Crete. And the thing about Mousterian rocks is they're only discovered in presence of Neanderthal fossils. As in, wherever there are Neanderthals, there were these tools called Mousterian rocks. And no other species used these. Humans didn't use these. Humans used more pointy jadestone rocks Neanderthals used Molsterians. That was just their habit. And these were found on Crete. And the cool thing about that is Crete is 40 kilometers from the island of Antikythera, and over 160 kilometers from the Greek mainland. And so when you think about how far a waterborne expedition that is, the chance of anyone surviving a swim to Crete is extremely low. If you check the climate records for the past 100,000 years, at no point was the sea level so low that you could make a land trek to Crete. It was always a waterbound island. And so it's quite possible that the first seafaring expedition in the history of life on Earth was not by humans, but by Neanderthals 120,000 years ago. And that to me, if that's not convergent evolution or common traits shared between species that evolved in similar circumstances, species of roughly equal intelligence, living in different periods of Earth's history, but having common interests, common features, if that's not that, then I don't know what is. Because when humans did take the modern stage, they began to build cities. They settled the oceans. They brewed beer. And yes, they traveled to space, but there's nothing about this that isn't hinged upon common features or common traits that have been sort of exercised by species that have come before us, species that we technically had no interaction with, just genetics in common with and interests shared. The first cities, Çatalhöyük, was about 9,000 years ago. That was kind of the first time humans started living together in societies, the point where you didn't have to be a know-it-all survivalist anymore. You could count on your fellow humans to do your survival roles for you, kind of like a multicellularity of sorts for people. Of course, we kind of outdid the Neanderthals with the ocean settling, but when we settled space last century, and more particularly in 2018, when a probe was launched called LightSail 2, it was by Caltech. This is one of my favorite space missions, like of all time. And the reason is because it wasn't that sophisticated, but it deployed a sail made of micromylar foil that was about a micrometer thick. And it unfurled something about as big as, what was it, 24 square meters? Pretty big, like the size of a tennis court in orbit. And it just faced the sun. And over time, over several months, just the force of the sun's light pushed this sail so far that it raised its orbit by about 400 kilometers. Now, 400 kilometers is not that far in the scope of outer space. But then again, Crete is not that far from Greece in the scale of the oceans. And so when I think about light sail, when I think about this sort of first solar sailing expedition, I think a few thousand years from now, we might be using this so commonplace that a trip through space on a solar sail might seem as commonplace as a cruise ship to Crete. Sorry, to Crete seems to us today. But anyways, the point is, if you look at sort of the past 4 billion years of life and the amount of common traits that we've shared, and if you look at just the discoveries that humans have shared across their history, pie, beer, and you think about how many chances for, common grounds those have held, and then you think about the fact that since we started looking for exoplanets in the 1990s, we have discovered over 5,800 confirmed exoplanets, 55 of which are Earth-sized, rocky, in the habitable zone around their stars, sun-like stars. When you think about that, and you think about the fact that we have had radio telescopes pointed at the sky since 1988, the SETI Institute. Is it 1988? Correct me if I'm wrong. But anyways, if we someday receive a message like a hydrogen atom, or the digits of pi in binary, or even just ones and zeros, trying to paint out some kind of number or element or genetic structure. Maybe it's just some curious civilization's way of saying hello. Anyway, that is the premise of my book, and I'm really excited to share it with you. The idea that even though we come from very distant parts of Earth, even though we and other species come from distant parts of the tree of life, and even though we are a distant planet with countless planets scattered throughout the void, there might be common ground that we find between us and other species. And with that, thank you very much for watching. Cheers.
That was incredible, Nathan. I absolutely love it. And Wow. I can tell you when I originally was going to introduce you, I was going to start off by referring to you as cousin, specifically for that percentage chance that you had shared in your book. I thought that that was fantastic. Um, I am going to open this up for questions from everyone before I ask anything, and I'm actually going to bring our Space Club, our John Abbott Space Club co-president Tristan Wilson beside you here. And Tristan is going to moderate the Q&A for us tonight. So, Tristan,
Hello.
there's a few comments already in the chat, but yeah.
Yeah, okay. Um, First off, I'd just like to say that was a very interesting presentation. Really nice, really good, in depth, and just overall, that was very interesting. I think everyone else here shares the same things. There seems to be, I don't know how, I guess we don't have a time limit for this. So,
Just open it up for
yeah,
questions.
if there's any.
Actually,
Any
first off,
questions? And
Dovid, did you have anything you wanted to add in to the thank yous?
yeah.
Only that
Mhm.
this was surprisingly good. I mean, I know Nathan from when we used to do that young people's group years ago, a number of years ago. I'm sorry that that hasn't continued, but I thought it was surprisingly good. And as I was listening to you, I was thinking of where you're going to be heading in the next years and decades. So I'm expecting to hear a lot out of you in the next years and in the next decades. Congratulations. Good work.
Thank you so much.
Do you have anything to share about your next steps? You're at the point where you're deciding. Have you decided?
Well, right now I'm going to UBC for astrophysics and arts and science. So
Wonderful. You get to do both. I'm so happy. Do you already have, well, I know you've gone on and off of campus at Victoria several times. Have you met up with people at UBC already?
I've taken a tour of the campus. It seems pretty nice. So
It is. It's a nice area. And with your experience already at Vic, that's going to help with Dominion and everything there. So you start in September,
Mhm.
right? Have you already had your graduation ceremony?
Yeah, that was like 3 weeks ago. It's funny, they give like an extra month of school after graduation ceremony, just either to give the committed students a superiority complex or to just see who drops off. I don't know. It's
Be
strange. It's
thankful.
very strange.
Data school decided that they would only do it after they finish, but then all the teachers are gone, so she doesn't get to graduate officially until November. And she's
Wow,
furious because she's like, we're all already off of doing our own thing, and then they're gonna call us back in for this.
that's
So
really strange, but
yes.
I hope she enjoys that.
Oh, she will. She will. So there was a question that was sent to me by text. So I'm gonna start the ball
Okay.
rolling here. The question was, when did you find time to become an expert in exobiology, archaeobiology, microbiology, uh, exoplanet work, everything? Like this is such a wonderful work of depth and breadth. How did you do it?
Um, okay, it actually kind of started as a CLE project. My school has this course called CLE or Career Life Education, where you do this little like capstone project where you refine a skill of yours. And I decided that the skill I wanted to work on was research. So I ended up writing to a bunch of scientists from, I think it was one from Penn State, one from UVic, one from UBC, McMaster, and it was one more place. I can't remember. But anyway, I sort of just asked around. Um, The other place that I got most of this from was arxiv.org. It makes no sense at all why you would publish papers in Nature magazine and publish free PDF versions on the Internet Archive, but I'm too afraid to speak out about it because I might jinx it. So I'm just going to ask you all to hush up about that and hope that we can keep doing this for generations to come. But anyways, that has a fantastic supply of resources of free studies that were published in paid subscription journals. And yeah, and then just asking scientists about that, getting their opinion, getting that proofread by them, and also just being able to attend events like these, honestly. This is what I love to do. Like the Global Star Parties was really got what got me into that community, and then getting to do talks at my local observatory, hanging out with RASC, and the cosmic generation was definitely foundational. So yeah, that's where I found time.
So we can expect you to be involved at the UBC Astronomy Club and the student design teams and things like that.
Have they got a satellite design team?
They have a rocket and satellite design team there.
Nice. Okay,
The
I guess
question is how much of it is the engineers and how much of it they let the actual scientists come in.
that's fair.
Questions from the audience.
Doesn't seem to be any so far. Don't see.
So we have one of our alumni is doing an astrobiology graduate degree, and she read a little bit about your book and messaged me to ask you whether astrobiology is a passion or whether the biology part was the connective layers and it's the astronomy that really is the passion.
I think astrobio is really cool, and if I had the chance to take part in a research project, I would in a second want to do that. I think for most of my life, it's been astronomy, with biology being, yeah, the connecting thread between it all. But also, like, something I've realized is if you're in astrophysics, sorry, astrophysics is too general, sorry, too specific. If you're in astronomy, like, I'm sure you can relate to this, Kareem. Astronomy relates to literally everything ever.
It
Like, you
does.
can append the number of suffixes that are astronomy and prefixes that are anything, like astro and then blank. It's more than any other field I've ever seen. Like astrochemistry, astrobiology, astroarchaeology. I think there's astroanthropology too, which is like the study
Yes,
of
there is.
civilizations and the stars. I even saw a paper for astrodentistry. I think there's something about like the study of tooth decay in microgravity environments. It's
Yeah, it makes sense. Everything is
Yeah,
different in
yeah.
microgravity. So, wow. Um, um,
Yeah, we got a question here. Someone's asking if you know of any good star parties around Victoria.
around Victoria,
Yeah.
the star parties at the Dominion Astrophysical Observatory, West Saanich Road, the center of the universe. Um, it is actually at the center of the universe, and I can explain why if you want. But the center of the universe on Saturday nights all summer, and I will be at most of them. So yeah, I think that's the only major star party in Victoria. Although sometimes RASC has private events at Cattle Point,
yeah.
but those aren't really scheduled. Someone just pops up and says, "Hey, we should do that." And then people are like, "Yes, we should do that. Want to bake cookies? Yeah, we'll bake cookies. Who's going to bake cookies?" It's usually me that responsibility lands on. So I'll probably see you there too.
Wait. What's your favorite cookie then?
My favorite cookie, um, that's a tough one. I think,
I thought this whole thing started with you becoming very upset about cookies and like becoming like the enemy of cookies because they took you away from the lunar eclipse impact.
okay, it made me the enemy of Chips Ahoy vanilla brand TM, but it didn't make me like I'm still every other brand is still a friend to me. And because cookies are such a competitive market, Chips Ahoy isn't exactly friends with any of them either. And you know the old proverb, the enemy of my enemy is my friend. Therefore, all cookies except Chips Ahoy are my friend. And so I think to answer your question, my favorite cookie brand is, sorry, brand, probably Viva Puffs. It is the lifeblood of RASC. But in terms of homemade types, I think frosted shortbread absolutely has to take home the cake, or cookie for that matter. And So,
We're gonna have to come to Victoria to try those.
Yeah,
Toasted
yeah.
shortbread just sounds awesome.
or spread the gospel and change the C in RASC from Canada to cookie.
I think Tristan is starting to think of
Yeah.
weekly cookie nights for the Space Club instead of weekly, discussion nights.
Cookies under the stars.
I
I
feel like they both incentivize each other. I don't think they have to
Yeah.
be mutually exclusive.
Oh no, what have you done? Nathan, our president Maury has now decided that our cookies have to be homemade from here on in. I can't buy the maple cookies that we always get.
Uh,
Well, you can, you just have to do something else to them.
Okay, so I'm adding Maury, and Maury's going to tell us how many cookies he's baking for us next week.
I am making a presidential decree. Cookies, homemade. First order of business, peanut butter.
So Nathan,
Motion to
one of the
approve?
people in our audience is Julie Claveau from the Canadian Space Agency, and she wanted to let you know to participate in NASA Space Apps this coming fall.
oh, yeah.
Because for that, you can definitely theme it with astrobiology if you want. You can theme it with communicating science. Tristan took part in it this past year.
Yeah. Yeah. Yeah, we made an app that, I mean, it was very rushed because you know how hackathons are, but we made an app that basically you set a bunch of parameters and it kind of gave you what the exoplanet would look like based on its distance from its star, chemical composition, and a couple other things. I can't remember them off the top of my head, but yeah, it's a fun, definitely a fun thing to do.
I'll check that out. Thank you.
I'll send you the link. We got to get you involved in that for sure. I'm adding one of our younger members, Luca, who you spoke about briefly, gave us a little bit of his history. But the reason I'm adding him is he has our Explore the Universe certificate most recent recipient, but he's also started into a little bit of astrophotography. And Luca, I think Nathan has some really amazing astrophotography stories if you want to ask him some of the things that he's captured. I've seen some at our RASC GAs, and my jaw hit the ground.
Okay, ask it.
I mean, I have a really unconventional method of taking pictures. You see, technically, I can afford a DSLR camera, but technically, I don't feel like getting one or learning how to use it. So what I've done basically is sort of amp up the capabilities of an iPhone to the max and see what I can get with that. It has taught me pretty impressive life skills, I would say, such as how to hold your hands laser still.
Oh.
But I suppose, like, what kind of pictures are you trying to take? I'm curious.
Uh, like nebulas and galaxies.
Okay, so that's kind of exactly what I'm not capturing with the phone. So you might actually want to invest in a DSLR camera if you do that, but I can't help you there.
He just got a smart telescope.
Ooh,
Yeah.
okay, that's really cool.
So Nathan, a few years ago, managed to capture the phases of Venus going all the way into the very, very tiny waxing and waning phases.
That's cool.
How close did you get to
Um,
opposition
let me just
or conjunction? Sorry. Oh, you have it. Oh, wow.
Oh, that's all
Um,
captured on iPhone.
yeah. Okay, wait, let me try
Wow.
to remember. Okay, the last picture. What was the last
Those were
picture?
mostly through your telescope view, right? Like just as you were going through.
Yeah, this was during the daytime. Shoot, where is it? Okay, never mind. It's not gonna work, is it? Wow, it's really not cooperating. Okay, I'm just gonna stop the share. Um, the last picture was taken during the daytime in the shadow of a hotel literally like a foot away from the edge of the shadow, with the telescope pointed, me lying on the floor, or like it was like in a parking lot or something, just lying in the gravel. My phone kind of lined up with this augmented reality Starfinder program, pointed straight at Venus, which was just past the edge of the building, and finding it at the finder scope and then putting it in the center and then getting like 2 seconds of exposure. And I think at that point it was like 2 degrees from the sun. So I think at a certain point, it gets close enough that you start to see the light sort of wrapping around the other end as it diffracts through the back of the atmosphere. That was pretty cool because I'd not seen that before. It's cool, like you can see the air of another planet from Earth. I found that pretty cool. So yeah, iPhone's not that great for capturing nebulae or galaxies, but they can take pictures of planets. And if you wait long enough, you can make funky time lapses.
Okay, I'll do that. Thank you.
Of course.
We have book recommendations, two book recommendations from Nader. It's he says The Greatest Show on Earth by Richard Dawkins and What is Life by Lynn Margulis. I'm not 100% sure how to pronounce that. He says also you probably already know about them, but if not, there you go.
Thank you. I'd heard of The Greatest Show on Earth. I have not heard of What is Life. And it's probably not 42, which sucks because I have read that book.
Me too.
Then you have to figure out what the question is. That's the other part.
Oh yeah, that's what Earth is for.
So this is the other part of what Nathan kind of brought to the global star parties was this embracing of the term nerd, which, when I was growing up, and I think when some of our other RASC members were growing up, that was kind of a dismissive or even derogatory term used. But this generation seems to kind of embrace that whole nerd aspect, nerd culture, and all of that. And so, one of the first things Nathan told me by email before he came onto that first Global Star Party is, so, okay, I'm a nerd. I was like, yes, great. So are we. And so being able to
I remember that.
Yep. So being able to just chat Douglas Adams and everybody's pitching in, like I love that.
Yeah.
That's fantastic. I've added Alexi to the spotlight as well. He is our social media member, but also helps run some of the observatory events at Bishop's University.
Yeah, hi. It's great to meet you, Nathan. I love your presentation today, and just hearing about you running the planetarium shows and all that is just something I'd like to do. I visited the Montmegantic Observatory, and they had their own planetarium kind of show there, and I would like to know if I want to get into that. Like, what exactly are you showing there? Is it just a specific topic, or do you kind of go through the whole thing of the universe essentially?
Usually in my shows, I start on Earth and talk about the constellations a little bit, and then what do? I check out the moon, and then Mars, and then the sun, and then I give the tragic backstory of Pluto, and then I zoom out to interstellar space and put on the constellations again, because the cool thing I like to show is how the constellations deform as you zoom out into the galaxy. Because they basically just played connect the dots with the stars, but then forgot that if you zoom out far enough, the dots start to move. And but I think it's pretty cool to show. And then zooming out all the way to the cosmic microwave background. So yeah, Edge of the Universe. The show usually takes like half an hour, and then I do a few of them each evening, each Saturday. So what that means is I basically get my volunteer hours for video gaming, which I think is pretty sweet.
That sounds like a dream.
So one more thing then, I guess we'll end with one last question, which you've set yourself up for with the entire presentation. Are we going to come across life elsewhere that's intelligent, that will have evolved into similar beings or off of a different nuclide base, and what's your feeling of what we're going to end up seeing, if anything?
Well, actually, what was it called? There was a telescope in Hawaii that in 2015 actually did pick up a regular message from seemingly an intelligent species. And they actually picked this up at 1 second intervals, this repeating message. It was quite impressive, actually. Um, and people were so curious what this ping sound was coming from because it was regular and it was not coming from a naturally occurring source. And yet this telescope was detecting it and it had an interval of exactly 1 second. And that was unusual because, you know, in order for this species to know what a second is, they obviously would have had to have previously received messages from us before. And so, upon further investigation, they actually traced this source to a Rolls-Royce microwave oven in the basement of the telescope, which was pinging every second for reasons that I need not explain. So, to answer your question in the most vague terms, we've already detected it. There's intelligent life shooting messages into our telescopes. But to answer your question properly, um,
Hold on, are you sure about that intelligent part of the intelligent life? I think we need to define that part too.
I should define that part. In that we haven't destroyed ourselves yet. I think, oh, should we, how many different definitions are there for intelligence? I'm gonna
I'm
I'm
just
gonna say
taking
we're
you off
intelligent
base,
for
you
the
know.
record.
I
Because if
think
I don't, then
our definition is very biased since we are defining it.
True,
that's fair.
that's
Yeah.
fair.
I mean, whoever encounters a message that we send will probably could potentially view us as extremely primitive, but then again, our lived experience only goes as far as this planet so far. So, for the sake of everything we know, we are the most cognitive species on the planet. So, I could say cognitive, the search for cognitive life beyond Earth, not necessarily intelligent. But what's this comment? Smart microwaves could be considered intelligent life. Yeah, this was not a smart microwave. This was an analog microwave. This was an unintelligent microwave. I'm very sorry to inform you. Um, If you look at the numbers alone, there are more planets in the universe, the observable universe, than there are grains of sand on Earth. If a billionth of those planets develop primitive life, and a further billionth of those develop intelligent life, there is still over 1 million intelligent civilizations in the observable universe alone. So the question, are we alone? Yep, Drake's formula, the Drake equation. Um, the question, are we alone and is there intelligent life elsewhere in the universe? I think definitively we're not alone. I think it's pretty safe to make that assumption. Whether we will make contact, I'm not sure. But whether that was a third part of the question that I forgot.
Oh no, that's fine. That was
Your personal feeling about it. That
Oh,
was the third part.
my personal feeling is I write a lot in my book about the Fermi paradox, but I think it's quick of us to assume from the one data point we have that the only reason we don't see anything is because life is inherently self-destructive and everyone else has blown themselves up. I think, first of all, it's a bit of a bleak outlook to have on the future of our species. And second of all, yes, we have one data point. We also have the fact that space is a little bit large, citation needed, and the fact that our galaxy is vast, 200 billion stars, that life may not be nearly as common as we make it out to be, and the fact that life, from everything we've seen, has progressed past all five mass extinctions. This is why tardigrades are 100% my favorite species. They're like, yeah, Ordovician, Permian, Triassic, Cretaceous, KT impact. And then they're like, okay, and they're still here. So life is really robust, resilient, and so I have faith that the reason that we haven't made contact is not because life is destructive. My personal thought is we just truly haven't encountered it yet.
And Julie makes the point in
Yeah.
the chat about which part of life we're talking about. Is it energy? Is it cells? Is it aerobic respiration? Is it carbon-based forms only? And this is the joy and the wonder of astrobiology, exoplanet research, and the search for life. And so with that, I'm going to thank you, Nathan, on behalf of the RASC Montreal Centre. And I will also invite you, if you want to stay for a little bit. A lot of people wait till I stop recording to ask anything or to chat. So we'll stop the recording and then we'll just open up for general discussion. Thank you, everyone, and stay tuned for the next public events, which will probably be in August for the Perseids. With that, we're signing off.